we could record this for them, so I've just hit record.
Okay, one more information. So this webinar will be recorded, so just to know everybody. Okay, Brian, it's your turn.
Okay, so can everybody see my screen now? Yeah. So, Ratislav, you just confirm that you can see my screen?
No. I cannot see. So did you choose the share application?
Communicate, yeah.
Okay, so wait a few minutes, maybe just a few seconds.
It's okay, I'm just bringing it up just now.
Okay, so now I can see.
Okay, good. Okay. So hopefully everyone can hear us okay. You should be able to see the front screen, which is just the introduction. SOS are our local distributor, and we've been asked by SOS to introduce to you some of the key benefits of our FTDI X-chip series. Now, the purpose of the training today and the webinar really is just to start to look at what are we doing as a company, where do our USB solutions fit in, and what are the key benefits of the FTDI X-chip series. So, alongside me today, I've got my colleague Gavin Moore, who's our Senior Engineering Support Manager. Gavin will talk you through some of the technical features. I'll give you an introduction into what we're doing and what we're trying to achieve with the and then we'll go on to look at some of the areas where we can help you to utilise USB very easily. What's probably worth saying at the moment as well is if you just keep your microphones on mute, as Ratislav requested, then hopefully we'll get less disruption on the webinar. So FTDI, we're a privately owned business. We have our headquarters in the United Kingdom, in Scotland, and we are still managed by our founder, Fred Dart. We do, however, have a global team. We've grown quite considerably over the last few years. We have facilities throughout Asia and America, along with Europe, and we primarily sell our goods through our distributors. Our distributors at SOS are all technically qualified, and for that reason, they are why we selected them. This really just shows that FTDI as a company, we're continuing to grow. Now, using those growth figures, we're continuing to invest in our staff and our new technology. So, considering FTDI for a current design is also recommended for longer term. We're looking at new ways to improve our products. That's one of the ways why we released the FTDI X-chip, as you'll see shortly. And as I've said, this is all available through the guys at SOS. What the FTDI offer that helps us to make your USB usage very simple? Well, basically, we are here to make USB very easy for you. We offer all the drivers. It's all royalty free. There's no hidden costs with FTDI. We support all the major operating systems, your Windows, Mac, Linux, and recently we've also expanded out to look at Android. It's not something we'll cover today because it relates to a different product, but you can see from this that the FTDI are continuing to support all of the major USB interfaces you can encounter, and therefore we can help with all of your design needs. We're also continuing to make application support more and more readily available through our website, through our distributors, and we'll give you a lot of application notes. The message is you do not need to have a large understanding of USB in order to use FTDI products. We will do the USB implementation for you. You quite simply have to concentrate on what's more exciting for you, for your application. Now, whilst we're fundamentally an IC or a chip provider, that's our main business, we do, however, offer a much more wide-ranging approach to USB. In the last 6 months of 2012, we released over 30 new products into the marketplace, and that ranged from chips to modules to cables, anything that is required for USB development or implementation. You can see on this screen here, just in the top right where my mouse is, it's a typical one of our chips. The second image is not possibly what you're really looking for in a common module. This is a simple evaluation board. We call these breakout boards. This is a simple way to evaluate our chips and evaluate our software and see how easy it is to use our goods. We've also got the more typical dual inline module, offering a much more comprehensive evaluation technique. And then if you maybe have an old serial product that you want to share, we also have our cables. Today we're going to focus on the FTDI X-chip series, which you can see in the bottom left of this slide. Now, historically FTDI have come from a full-speed USB single-channel solution, which is the FT1248 and 245B. We then developed that to a reduced component version of the R-chip, which is possibly our best known product to date. We've also got high-speed solutions in single-channel, dual-channel and quad-channel, and then we have a full-speed dual-channel solution. And over here we have our general-purpose bus. But for the purpose of this presentation, and for the purpose of the future of FTDI, I would suspect for full-speed USB, we're looking at the FTDI X-chip series. So, looking specifically at the peripherals where the X-chip's available, what do we want to offer you that's going to help you? Well, first of all, it's how long does it take your chip, your design to get to market. You may spend a number of months developing your application, your code for your controller. You don't want to spend a long amount of time working on your USB connection. We do that for you. It allows you to release your product much faster. We offer all the major interfaces, UART, FIFO, SPI, I2C. We also have all the different classes which are commonly used. Gavin will speak about these in a little bit more detail later. What we're trying to convey is that the X-chip works with all of these different features and it helps you to achieve your design in a quick time. This slide really shows what our director and our founder Fred was trying to do when he released the X-chip. The world's becoming more mobile. People are working with handheld PCs and platforms instead of physical computers on their desk. X-chip has a smaller footprint. It fits into the mobile market. We also have battery charge detection, which again Gavin will explain in more detail. But this works well and complements the mobile world, the handheld world, whereby you're always looking to charge the power into a mobile device. But what we've really wanted to do is to really sort of enhance the features of the known benefits of FTDI. And that is USB made easy. You can design it easy, and you can take all the principles from our past and put them in a modern solution. You'll see shortly, we have a 14-chip package, so 14 packages across the family. I've mentioned all the different interfaces and the operating systems. We're also now looking at 10-pin and 12-pin DFN footprints, like really now starting to focus on board critical space. You'll see this slide a number of times during our webinar. What we're really looking to do is to try and allow you to understand what we're doing for each of our different interfaces. So we'll have our I2C, we'll have our FT1248, which is an enhanced version of SPI generated by FTDI. We have our common USB to UART interfaces with the 230, 231 and 234, And then we'll also talk to you about the other interfaces we have with FIFO. Just to start to summarize how you get from initial consideration of USB to designing in an FTDI product and what the feature benefits are. This is one of our breakout modules, specifically for the FT1248, which is an I2C. We also have the UART and the SPI versions there for you to consider. Basically, this module plugs into the USB socket on your PC and allows you to evaluate the hardware. It's a very, very simple way to evaluate the USB chip at the outset. What you'll be more common with, and if you're looking to perhaps design a new board, is a dual inline module. Typical example is shown in the top right corner of this slide. Again, we cover all of our different available interfaces, allowing you to evaluate that hardware through a more robust and wide-ranging pin count there that you can really look at and start to evaluate specifically for your application. These are all available through SOS, and they're available in a short lead time at a very, very competitive cost. Many engineers are commonly found to have a USB to UART, or USB to serial, cable on their desk, and we're quite confident that we will find an FTDI cable on most of the desks found with the big engineers and your larger companies. But more importantly, I think it's also very commonly found with our smaller businesses and our hobbyists. Why is that? It's because our USB to serial conversion is robust, it's reliable, and it works with all the common different factors, be that operating systems or whatever it is you require. This here is the cable offered from our X-chip series, which is the Chippy X10. It's a 10 centimeter cable, and as you can see, it has a typical 9-pin DB9 with USB. This cable includes our IC within it. It really is a plug and play. If you're online, you will get your drivers free of charge there as soon as you plug in the cable. That's why a number of really good, strong design engineers like to look at USB from FTDI. They've used our cables, they've used our modules, they know we're reliable. What we'll do now, I'll pass you over to my colleague Gavin. Gavin will take you through each of the different sections of the X-chip family. As I said at the start, if you've got any questions, then Bratislav can raise these to us.
Yeah, Graham, we have one question here.
Yeah.
Mateloni is asking, SPI is good, but my AVR microcontroller project focuses on one wire. Any chance for a one-wire connection?
One-wire connection on SPI only?
Maybe it will be better. I will pass the microphone to Mate, and he will ask. Okay.
Okay.
So Mate, you're online now. You can ask the question.
Hi there. One wire, it's like I see, but it's a little different. With one wire, you can use only 3 cables to connect a device, and there are Texas Instrument devices like this connection.
Okay. So you're saying I2C or SPI?
It's like IIC, but it's a little bit different.
Okay, well, in a couple of minutes, we will be going through the block diagram of both I2C and SPI, and I can explain it a bit clearer then. Okay?
All right, thanks.
Thank you.
Is there any other questions at this stage?
No, this one question was the only one, so you can continue.
Okay. Go ahead. Thank you. As Graham mentioned, I'm now going to look at each chip within the X family. However, before we do that, we're going to look at some of the features of the FTX. Now, Graham mentioned the 232R device, which you'll all be very familiar with. And what we decided to do was, okay, how can we improve it? And the first thing was, let's reduce the size, let's save space on the PCB, and let's add in some extra features. And you can see here, the first one we did was battery charging, and this allows battery charging detection on mobile type products. The other and big advantage we found was we were going to reduce the operating power. The 232R typically runs about 23 milliamps, and you can see here that the X-Series is only 8 milliamps, and when suspended or sleep mode it's only 125 microamps. We integrated Crystal PLL and MTM memory, again saving board space and maximizing flexibility. Okay, we're now going to look at the series from the left-hand side. So we mentioned we've got I2C, SPI, UART in 3 different flavors, and finally FIFO. Let's look at the 200 XT and the 201. If we go back, you will see these are both I2C slave devices. And from the block diagram, it's clear we have an I2C master on the right. So it's a good point. All of the X series will work as slave devices. So this will be I2C slaved. This is just a typical schematic of how you would hook the device up. We have data sheets for every device within the series, so I recommend you have a look at them. At the end of the webinar, we can show you where to find these on our website. I2C rates are about 100 kilobits per second. We can have 400 kilobits in fast mode, and we have a 1 megabit fast mode plus. And finally, high-speed mode, 3.4 megabits. It's important here that we have what's called CBUS pins. Now, you'll see these in all of the chips. These are programmable, and they can be used as general purpose I/O, wake up, or battery charge detect. We will go into a bit more detail further on, but it's key to note that the X has 1 and the 201 has 6. Okay, USB for those tight slots. It's a USB to I2C slave bridge, and we mentioned speeds up to 3.4 megabits per second. Now, what's the difference in the two? The 200 XT is a 10-pin DFN, and the 201 is 16-pin. So we mentioned the CBUS pins earlier on, so that you can see the difference. Basically, you have more flexibility with the 16-pin, but you might only need to use one CBUS pin, so therefore you would drop down to the 10-pin, and this is our smallest package in the family. I also mentioned the low power 8 milliamps, so this is again for every chip within the series. CBUS configuration, and we mentioned also other options can be driving LEDs, clock out, battery charge detect. Internal 2 kilobytes of memory, and it can be programmed over USB or over the I2C bus. Another feature of the R chip was the chip ID, where each chip is given a unique number. We find customers find this very useful, and we also added this into this series. Another point is this chip can be powered either serial powered or bus powered. Typical bus power 5 volts from the USB line we find is the easiest circuit to get working. Okay, so now we're going to go to the 220 and the 221. And if you look back here, you will see this chip is USB to SPI. And we call this SPI the FT1248. It can either be 4-bit or it can be 8-bit. CBUS pins are both 1 in this case. And packages are 16-pin or 20-pin in the 221. You can see the block diagram here, and the 1248 bus masters on your right-hand side. It's a flexible interface. You can choose 1, 2, 4, or 8 bits wide, and extended 8-bit wide in the 221, which is in the 20-pin package. Now, the previous question regarded how many pins, so in this case the data is just used over the MIS-SIO. The MISO at the bottom is just used as a status pin, but you also have to have clock and you still need to have your slave select. So in this case you can minimize it to 3. Okay, what is the 1248? So it's a synchronous parallel serial data bus. It's up to 8 bidirectional lines. The MISO, as I mentioned, is a status signal only. It's not used for data. So the MOSI is used for data out and data in. The X device in this case is a slave. And the bus width is determined by driving specific data lines low during the command phase. So on the left-hand side, you can see the variable width up to 8 bits. And you've got your clock, slave select, data pin, and your status. I mentioned at the beginning our data sheets, but we also have a great amount of application notes. So whether the way I look at it is the data sheet will give you the exact data on hardware. How is the chip pinned out, for example? How is it powered? But we have application notes that will go into specific details of protocols, and in this case, the 1248. So we have the app note 167 and app note 206. We will show you where you can find these in the website later on. So advantages of the 220 and the 221. The 220 is a 16-pin, and obviously we mentioned the 1, 2, or 4-bit wide interface. However, the 221 is a 20-pin, and it gives you up to the 8-bit wide interface. It functions similar to SPI slave, but with higher throughput. This is the advantage over the normal SPI slave protocol you're used to when you're using both MISO and MOSI as in and out for data. Again, low power consumption, typically 8 milliamps, and of course the CBUS pins can be configured. We mentioned each time the USB battery charging detection function. I'll go into further details of that later on in the webinar. Okay, now we're on the 230, 231, and 234. So where do they fit into the family? So this is the 3 that are all UART devices. And the difference basically is what handshaking you need to use. The 234 we have just recently announced, and it is a very small 12-pin DFM. However, it has 1 CBUS pin. If you're needing slightly more flexibility, you would go for the 234, which is the 4 CBUS pins and full UART. Finally, the 230, again it has 4 CBUS pins, but it's what we call basic UART. It doesn't have the full handshake capability. And you can see it's in a 16-pin, so it's a very small package. If you compare that back to the R-chip, which came in Q&L, they were both 28 pins. So it's a dramatic reduction in size of the actual package. So where would you use these? So basically USB to RS-232, 422, 485. Simply, all you need to add is your level shifter to shift up to the levels of 232, 422, or 485. You can see in the block diagram here, your PC on the left-hand side will be your USB host, and the board here is using a USB Type-B connector, and the 230, 231, 234 will be a UART slave. We've obviously, with the success of the R-chip, we expect this to be as successful in the fact that it is smaller and less power with more configurable points. The UART obviously is a huge protocol out in industry, specifically to control systems. Another way to look at it is it's a useful way to interface UART into an embedded system. And you can see in this case, we've got a micro, we've got the 230, for example, and the CBUS pins connecting to give you a general I/O, and obviously your I/O buses from the micro. So an easy way of adding UART integration from your micro to a computer. Okay, what's the advantages in these 3 chips? So you can match your UART configuration. Again, we want to reduce space on the PCB, as we all know, reduces money. The 230 is a 16 pin, and it comes in SSOP or QFN options. As I mentioned, we call this the basic UART, so it's just got RxD, TXD, RTS, and CTS. The 231 we call the full UART or full modem control, has every handshake pin available. However, to accommodate that, we need the bigger package. It has the 20 pin SSOP or QFN. Finally, the latest one, the 234, a very small 12 pin DFN package, but where the reduction here is in the handshaking, it only has RTS, CTS. However, this is not a problem. We know a lot of customers that use the R chip with no handshaking at all, or just using these 2 pins. It's full speed, so you'll get up to 3 megabaud data rates, and like the previous chips in the family, it's 8 milliamps typical run power. Again, configurable CBUS pins, and obviously the battery charge detection, which I said we'll get to later. Okay, well, the final chip in the family is the FT240 or the 240. You can see it on the right hand side. This is a USB to FIFO device, and it's up to 1 megabit per second. In this case, it's 2 CBUS pins. And this one actually is the biggest pin count package in the family, 24 pin. It's a USB to parallel FIFO interface, and it can be integrated very easily into an embedded system. In this particular diagram, you can see again USB host, i.e. the computer, laptop, whatever, the FT240, and this time we're connecting over a FIFO interface to a micro DSP FPGA. Again, we can configure the CBUS pins, and in this device it has 2 CBUS pins. In this diagram it's shown as one has been a GPIO. What's the advantage? Okay, so it's a reduced pin count. This chip is probably similar to our FT245, which was the same as the 232R family, which was USB to FIFO, 8-bit wide FIFO. Again, low power consumption, 8 milliamps, and this time you can configure the CBUS pins, but in this case you probably LED, or as in my previous diagram, you would just use them configured as general purpose I/O pins. Again, battery charge detection and the chip ID security. As you can see, these advantages are very similar in each of the chips within the family, but the key point is that the flexibility in what protocol you'd like to use. Okay, so we'll just stop here for a minute before we go into the battery charging. Have you had any questions on the last section?
Yes, there are some questions, so I will pass the microphone again to Mate. He has one question.
Hi, thank you.
Hi.
Via USB, is there any special program required?
In the USB, no. If you plug the USB into the computer and the computer is connected to the internet, one of our key selling points is our drivers will just download, because our drivers are certified. That means if you're connected, the Microsoft Update system will go off, look on our vendor ID and product ID and go, yes, FTDI have default drivers, download them to that system. If it was Windows 7 or Windows 8, as I mentioned, if it's connected to the internet, off it goes and it will download them automatically. If it was an older system, maybe Windows XP, you can also manually set the auto detect to start itself, or you can download the driver straight from our website. So no USB prototyping is once it's installed. In the case of the UART chips, it would give you a COM port, a virtual COM port.
All right, thank you.
Okay. Hopefully that clears out. What was the other question?
There is another question from Attila said. So I'm testing the microphone to you. Attila, you can ask.
Hi.
Hi, Attila, we can hear you. Attila,
hello, do you hear me?
Yes.
Yes, hello. You said something about the chip ID security feature. Can you explain a little bit that?
Yes, it was inherited from the 232R chip, and basically it's a unique number to every chip that is made. So you could write this into your code if you wanted for some, basically security. We have some application software that show you how to use it, and we have an application note that we can send to you as well. But basically a unique feature where every single chip that's manufactured has its own ID.
Thank you.
You're welcome.
Okay. There's no another question, so we can continue.
Okay, thank you. Okay, next section, power delivery, battery charging, and detect. One of the enhancements we added to the X-Series. So USB, it's a major vehicle for battery charging. You'll know yourself, you'll plug your phone, your mobile phone, your smartphone into your computer or into a USB wall socket to charge it up. So there's more and more uses of battery charging in the USB world. The chip was designed with the USB battery charging specification. This is created by the USB forum, and they have a specification for every USB, whether it's host, slave, or in this case battery charge. So the new version of this was released, and it was version 1.2, which enables faster charging, but it provides different types of chargers. You can have a standard downstream port, a charging downstream port, or a dedicated charging port. The dedicated charging port you can see here is TCP/wall. That basically means mains electricity, plugging it into the wall via a USB power adapter. In that case, just to be clear, it's not connected to a computer at all, so no data can flow. Whereas in the other two cases, while we're charging connected to a PC, you can send data forward and back. Battery charging is not standardized. Each peripheral manages the charging independently based upon the battery profile. So this is just with a wee bit built-in intelligence into the chips to make sure they don't overcharge a device. I would obviously have a dangerous situation. Okay, and this just gives you a block diagram. If we look here on the right, we have this LTC device, and basically I'll move on a slide to show you this is a battery charging chip. Our X-chip, in the previous slide, is controlling the battery charging, but it is not carrying out the battery charging. So this is a key point. Some customers have been confused with this one, so we've tried to clear this up with these two slides. So the X-chip is controlling the battery charging, and the LTC chip is carrying out the battery charging. When we mentioned, in this case, a dedicated charging port or the standard downstream port, PC USB port. We mentioned CBUS pins earlier. We would have to configure battery charge detect on one of your CBUS pins, power enable, and sleep. Obviously, the idea of the sleep is if a sleep command from the USB host is sent to the X-chip, you also want to shut down your battery charging chip. So there has to be this connection, so they both shut down at the same time. This is an example where maybe the X-chip is connected to a laptop, and it's charging via the X-chip to the LTC, eventually to the battery on the right hand side, and you close the lid of the laptop, which will power down the laptop itself and put it into sleep mode. So we need to pass that signal on. So the sleep would come from the host, and it would close off our X-chip, and simultaneously a sleep command will be sent to the LTC chip, and that will close down at the same time. Therefore, no more power is being charged to the battery. The reason for this, if the charging was still carrying on with no control from the X-chip, it would have no idea how much charge it has or still needs. So that's basically a safety feature. Okay, the LTC 4053, it's just one we chose to use on a couple of our modules. There's a lot of standalone battery type charging devices, but we found this one very flexible. And you can see, if we compare the signals on the bottom left with the LTC to our X-chip, okay? VCC obviously is the input power supply. Back is the charging current. Prog is the charging current proportional to the current sunk from this pin. And shutdown I mentioned. And the last one, NTC, is connection for a thermistor. This basically monitors the temperature of the battery, so if it starts exceeding a specific temperature, it will switch off any further charging. Go down to the X-chip. Now we have our BCD, which is battery charge detect. We have our sleep, and we have our power enable. So the battery charge detect, it's a dedicated charging port, and it's used to select a resistance value on the prog pin for the mains adapter charging. So it's basically switching between either mains adapter charging or PC. Okay, and on the right hand side you can see the different types of chargers. We've got the dedicated mains adapter, so it can charge up to 1.8 amps. So as you can see, you'll know for yourself the fastest way to charge your phone would be connecting it to the wall. So that's going to allow you the 1.8 amps. If you connect it to the PC, you're going to reduce that rate to 500 milliamps. There's a reason for that. The reason is the USB specification. It will not allow a USB port to increase or give out more than 500 milliamps. And it's basically to protect the computer from overcurrent situations. But what is the advantage of still being connected is you can still send data back and forward through the X-chip. And as we mentioned, the suspend scenario, there'll be no charge at all. Okay, so we mentioned the CBUS pins, and we can choose, this slide's again just showing the whole family, but just to give you an idea of how many pins each chip has. The 201 has 6, down to 1 on the 200 or the 220. 1 can still be enough to set up the battery charging, and I'll show you that in a minute. However, the first one is doing it with 2 CBUS pins. You can see not all the devices in the family have 3 spare, so anyone with a 1 is not going to work. So you would then just use the 1 CBUS option. But in the 2, it allows you to set for sleep and power enable. And the sleep, again, is controlling the LTC, which is the actual charging chip. And it uses the power enable to control the charge. As we mentioned, connected to the computer, so we're limited to less than 500 milliamps. Okay, now the rest of the chips in the series only have 1 CBUS pin. So in this case, we only use the battery charge detect signal, and this will enable or disable the LTC charging pin. And it will only charge from a dedicated charging port. Okay, so we're now at another break where we we're going to go on to application and usage examples. Do we have any questions on battery charge?
No, we don't have any official questions. So if anybody has a question, so please write it in the Q&A window, and we can answer them. So there's no question yet, so we can continue.
Okay, thank you. Okay, so we've gone through the protocols of the available chips in the family. Where would you use them in the industry is the next section. And if you want to integrate an USB interface using UART, FIFO, I2C, SPI, or FT1248. So we have a wide selection of the devices that are within the full speed. And you can see in this block diagram, it's the FTDI chip, i.e. any one of the X is your bridge chip. And in this case, you're bridging from a PC to a micro, DSP, or an FPGA. This could be for programming the micro, it could be for debugging the micro, or it could be simply as a barcode reader. The other big opportunity we're seeing is electricity supply meters. Also some other options, thermal printers, medical displays. We'll go into a bit more detail. Many apps, not just development systems. You can see our family of X chips in the middle here, and we mentioned firmware upgrading. Control could be UART, and we see this in a big way in heavy industry manufacturing factories that are all connected via RS-232. All you need is one of the UART chips and a level shifter to give you the 232 voltages. And we even have simple HID devices like a smart keyboard or a USB dongle. On the right, you can see point of sales and medical devices. Now we'll go into a bit more detail on these ones. This was another example, and this is using our FT231. And if you remember back to the family, this is our UART, and you can see with a computer as a USB host, we're connecting straight into this system communication interface of this solar power system. It can use either RS-232 or RS-485. Again, all you need is the UART and the level shifter to select the voltage level you require. Okay, there was a question earlier about drivers. So this slide's just to give you an idea how varied our support for drivers is, whether it be Windows, XP, Vista, Windows 8, and even Windows 7. Every time a new driver comes out, the software team will be straight on the case of updating our drivers. And as I mentioned, our drivers have to be certified. And again, the certification allows you to download straight off the Microsoft update without any pain, basically. Very easy to do. We mentioned earlier as well Linux, Android, and Apple's OS, Mountain Lion being the latest one. Okay, now let's have a quick summary of the whole series of the X's. And we have that basically, if you think of the X chips as bridge functions, USB to something, UART, full UART, FIFO, I2C, SPI, Sync FIFO, and our own FT1248. Operating system support royalty-free drivers. We've gone through the Windows, Mac, Linux, Android, etc. It's simple migration to USB. Easy to use chips, and the drivers are ready now. We have 14 years experience in USB marketplace, so we do know these chips, and we have a good support network to help you on your way if you're deciding to take this route of one of our X-Series. Okay, we're just going to head on to tools and development. I'll just stop and see if there's any questions in the last section.
No, there's no questions yet. So once again, if anybody feel free to ask, you can just write a short question into Q&A window, questions and answers, or just chat me and we will ask to Gavin or to Graham.
Yes, and even if any questions are thought of after the webinar, you'll be able to get our contact details and you can send an email direct.
Okay, perfect then.
Okay, so tools and development. How is it easy for us to sell our chips? So what we like to do is we come up with software utilities to make the easy integration of our USB devices. We'll start with USBView. This is a very simple tool that allows you to read all the settings of the devices connected to the PC. Now, this is useful in the case of vendor ID and product ID. I mentioned earlier how we have certified drivers. However, you may want to personalize your driver. And to do that, we allow blocks of product IDs to be given out. What would that mean for you? So basically, if you use it with our vendor ID, you can see here, 403, and your own unique product ID, this gives you a unique point for your product. You could also add in some text. So you can see here, USB to serial converter. That could be the name of your product. Then what we recommend is we would then check out your driver, and you could certify it by going through a small process with Microsoft, and once your driver is certified, it will then be able to update over the Microsoft update. So very, very good way of having a kind of unique driver, but also it's still got the great flexibility that can be downloaded straight over the update. FTFrog. I mentioned the CBUS pins quite a few times, and how do you configure them? So they're configured using the EEPROM within the chip, and FTFrog is a software utility that allows you to program and change these settings within the EEPROM. So we could change the product ID, or we could change the configuration of the CBUS pins. If you remember back previously, that could be an example for the battery charge detect, the sleep command, or a general purpose IO. FTINF, this is a tool to allow you to edit the INF file. The INF files are integrated within the driver, and these give the specific information to the computer when the device is plugged in. So again, if you wanted to change the product ID, if you had already used FTFrog to change the product ID here to your own unique one, you would then need to update the driver so that the driver and the computer can talk to it. So you would use this FTINF to edit the product ID within the driver itself. CDM uninstaller. Now, we've seen problems in the past where customers have been using FTDI chips for a while, and they've got maybe one or two versions of our driver. This can cause conflicts, so we always recommend you clear up the PC first. So we come out with this utility, and this basically you run this, and it will delete all previous versions of FTDI drivers that will allow you to install our latest. At the current time, it's 208.28, and after this is run, you know there'll be no conflicts with older drivers. Graham mentioned earlier, we also recently have added Android support. Now, we did have our old D2XX driver available, but there was a problem. You had to root your tablet or mobile phone, which isn't very useful because, you know, the manufacturer warranty is broken. So we came up with a better version, and we call it our Java D2XX driver. This can be installed without routing or any permissions set, and it will seamlessly sit on the tablet or phone. And if you were to plug in the chippy cable you saw earlier, which is the 230 X-chip on it, it would automatically be recognized by the Android operating system and communication would be ready. To take advantage of this, we have this driver available on our website, but we also have some apps. And one of the apps is a simple UART loopback test. And it's a very useful way of adding UART to an Android device. However, you do need to know the Android device needs to be a USB host. It's available on Android 3.2 and later. I mentioned the host, it can also be an on-the-go. Some of the mobile phones allow the use of an on-the-go cable, which means you can change between host and slave. Okay, that's the end of that section. I'll now pass you back to Graham unless there's any other questions, and if not, Graham will take on the next section.
Yes, we do. We do have questions. So we have a question from user. So I can pass the microphone to you. You can ask directly. Oh, now your microphone is on. User, can you ask the question? So I have to read the question because user has no microphone. So I will read the question. So in the previous chip FT1248 there was no USB resistor, but now in the X-Series there are resistors and also two caps. Why they are not integrated anymore?
So the caps were just for noise. Let's see. That's schematic. Okay. So can you see that slide? Yes. Okay, so the caps are shown, would be recommended on our previous chip data sheet, but the resistors, you are correct, are required on the X-Series. I'm not sure of the exact reason why that was changed in the design spec, but I can certainly find out for you.
Okay, so we can come back to that one. If we just carry on unless there's any other questions.
Yeah, there are questions. So there is a question from Pavel. Is it possible to lock FTDI chip configuration to disable unauthorized changes, for example, to prevent end customers to make changes to configuration?
You could change the settings in the EEPROM. I mentioned the FTProg utility. A customer could change this. We don't have a secure program that would allow you to protect this. So yes, the customer could reprogram it using FTProg.
Okay, so another question. I tested your drivers about 1 year ago with Qt. Sorry to say that no dynamic linking was possible in Qt SDK due to unexpected crash that time. Can you tell me something about this? Static linking was okay. This experience was with R-Series.
So with Qt, what do you mean by that?
Okay, I will pass the microphone to Attila. He will ask.
Hello.
Hi.
So Qt is a programming environment. A lot of people use it because you have access to a very rich library, Qt, SDK.
Okay, I'm not familiar with that. So your question is, you try to use our driver with Qt?
Yes, but if I try to link the library dynamically during runtime, I experienced a lot of problems. But anyway, the static linking was okay.
Okay, so you see a lot of problem. What do you mean? Did you lose data or?
Yes, I lose data. I got messed up my data structures and so on.
And were you using flow control?
Sorry, what?
Flow control, handshaking?
The problem was before I do such a thing. The problem, I think it began at the moment of the linking.
Okay.
I think it's something incompatible with the drivers.
Okay, that could be a valid point. I could certainly get the software team to investigate this for you.
Okay, thank you.
Yep, if you could send me an email, you will have an email address will be shown at the end of the show.
Okay, and I think that the internal app ROM, it has to be write protected in some way. It was the previous question. I think that it's a good idea to write protect the app ROM to not be able the customer to change the settings.
I understand. Yes, it is a valid point because a customer could go in and change something, but if you don't tell them how to do this. But yes, at the moment we don't have a secure way of doing that.
Thank you very much.
You're welcome. Okay. Well,
okay. There is another question. Is it possible to protect internal memory through password, hardware storage for crypto keys?
It's basically a similar question to the previous one because the CBUS settings are held in the EEPROM. So no, we haven't got a utility to do that. But obviously, a few people are asking this. We can certainly look into this for you because it would be a software tool. But I know hardware-wise, there's not a way of locking the EEPROM.
Okay, Martin, is it okay this answer for you? So there are no other questions. You can continue.
Cool, we'll carry on then. I think what was worth stating at this point in time is that we're more than happy to receive the feedback and the questions directly or through SOS. We obviously learn what the customer requires from you guys, you're the customers. So, you know, it would be helpful if you could just email us with what you're trying to achieve and why you need that facility with the protection, and that will allow us to really go and push to get that development from our designers. So we'll take a few minutes now just really to look at the USBView and stuff. Let's see. This is really the design support side of things. Now, as I said, we're more than happy to interact with customers, with our distributors. Effectively, whilst the distributor makes a sale, we will happily support the engineer who's doing his design. Now, Gavin heads up a team of engineers. We try to answer every question within 48 hours. That's our sort of quality level. And we also have a team in America and a team in Asia. So we're answering questions 24 hours a day. So if you require any support regarding your selection of what's the most suitable product, do you require full handshake or part handshake there? Do you require any help with configurations or customizations? or perhaps even just to review your schematic, we'll happily do that with you. What I would recommend doing for the first questions before really coming through to a number of either SOS or ourselves, whilst our website is perhaps a little bit dated, there is a massive amount of information there that allows us to help you. Basically, the drivers, the data sheets, and I think more importantly, all the application notes and technical notes that allow you to begin your design really simply. These are all available on the website, and we'll start to show you where these are. So this is a simple screenshot of the FTDI chip homepage. Excuse me. If you look on the left-hand side, we've chosen the support option, and you can see there that there's a number of options as to what you want to go to, where the next level is. Now, I'm not an engineer, but I find I can answer a number of questions from customers simply by going into the document section, which I've highlighted here. Now, this is really simple to use. The data sheets, application notes, and the installation guides are very strong documentation. And I'd suggest if you're using USD from FTDI, perhaps bookmarking this page would be a good starting point. As we said, all of this information is all free of charge on the website and updated continually by Gavin's team. So why choose the FTDI X-chip series? We've covered a lot of this already. Effectively, the four main points which I would stress to you are the small footprint. Boards and handsets now in the mobile market, or even in the static product market, are becoming space critical. Now, there's two reasons. People like smaller products nowadays, but more importantly, it cuts your costs. So the X-chip series allows for both of those. You also look at what power consumption is required from the USB. FTDI's X-chip series does not have a high power consumption, allows you to operate with your controller and other areas of the application. And more uniquely for FTDI versus what our competition offer, and one of the big benefits we've got is we have the battery charge detection. And the key word really is the detection. That's what we're stressing here. You have to have your charging chip in addition to that, but for the modern world, detecting what power supply is coming into your product is key and critical. What we've also done is cut our costs. So what we're doing here, a number of you have already looked at the R-chip, as you've mentioned in some of the questions. So I've really just given you an example of what SOS would be charging you in comparison. So let's say you want to buy 5,000 pieces of a USB to UART IC. You can see there that would cost you $2.05 if you were buying the R-chip. Now we've maintained all the drivers, we've maintained all the benefits from the R-chip, and we've put that into the X-chip at a lower cost. So you can see already you've saved at least 50, 60 cents per chip. Over 5,000 chips, you can see it's a considerable saving for you. Alternatively, looking at the FIFO, you're going to get the same discount that you're going to see there. Small volumes, you're saving $1.50 per chip. It really is a much more cost-effective solution, keeping on the low power, lower space, and more importantly, continuing with our USB made easy principles.
FTDI are pleased to direct customers to a preferred routing.
Sorry about that. Basically, the setup of FTDI is that we make around about 90% of our sales through our distributors. We don't sell through multiple different distributors. We sell through qualified technically competent distributors who can offer you a local service. We have, for SOS, we have Tibor. Tibor obviously could help you with some support there from SOS, or he can come to us. Similarly, you can come to us directly. What we're suggesting is you don't need to be a USB expert, because SOS and FTDI can do that part of the design for you. Really, what this just shows, we're contactable. Please do not hesitate to contact us. We're here to help you. You can see the details there. For any support inquiries, it works on a ticketing system. So if you email support1@ftdichip.com, then the guys will process that for you. If you feel that you've not had a fast enough response, please contact myself directly, graham.simpson@ftdichip.com, and I can go and speak to the support guys and ask them to prioritise your question for you. And this really just shows where FTDI are located. As I say, we have a global network. If you're working for companies and perhaps you're working offshore, or maybe you have colleagues who are looking for local support and they're based in America or Asia, we can offer that support for them. So I think that it's been very good for SOS to offer this for you. I'd like to pass on some congratulations. SOS were good enough to, sorry?
Yeah, we have a one question, technical question. So maybe before this official ending sentence, it's better to ask a technical question.
Yeah, sure.
Yeah. So Attila, I'm passing the microphone to you. You can ask.
So I want to ask you about the X cables. Does they provide true tension levels at the RS232 sites, or we have there only some small tension like plus minus 3 or 5 volts? Because you know it's a true RS232 cable has to have plus minus 12 volts voltage.
Yes. So the chip can run at 3.3 or 5 volts, that's correct.
Yes, we know that.
Okay.
But my question was about the cable. Does the cable have any converters built in?
Okay, the actual Chippy X cable.
Yes, the X cable. Yes, that's
the X-chip. It is powered by USB, so it will 5 volts USB.
Okay, but this not the question was not this. The question is that the X cable, yes, the final product, does provide a true plus and minus 12 volt voltage level.
Okay, so you're asking what the level shifter is giving out on the other side?
Yes, yes.
Okay, I believe it is plus and minus 12. I'll need to double check the data sheet.
Okay, thank you.
We will send you this information. Okay,
thank
but I
you.
believe it will be because it's just normal RS232 levels.
Okay, there is another question. Could you tell some words about FT1248?
Yeah, what would you like to know?
Okay, Tardi Shandor, I will forward the microphone to you.
Okay, we'll go back to the slide. So the key part of the 1248 was that the MIOS is used for data forward and back. The MISO pin is just used as a status pin. Normal SPI would use the master in slave out as a data pin, and the master in as also the data going in the other direction. But in our case, we're using one signal to do data in and data out. But it gives you flexibility if you can move this up to 8 bits wide, which you can't do in ordinary SPI. We have in this slide here app note 167 and 206 that you can download them straight from the website, and it gives you the full explanation of this protocol. So if you have a look at that, and then if it brings up any further questions, you could send me an email. Okay?
Okay. So Tardy Shandor doesn't have mic, so he cannot answer.
Okay.
But he will check it.
Yes.
And there is another question from Pavel. So can the unique ID of FTDI chips read by devices behind them? I mean, not by computer, but by microcomputer connected to FTDI chip, making it possible to use ID as a general serial number in all applications.
So yeah, the chip ID can be used as a unique identifier, but not as a serial number. The serial number can be changed within the EEPROM settings. The reason for that is when you plug a USB slave device into the PC or a USB host device, they communicate by the vendor ID, product ID, and serial number. So you have to have a serial number of some sort, and so it has to be able to be configurable if your customers want to change the serial number. So the chip ID is separate from the serial number, but it is unique, and you can use our software application to read the unique chip ID number. So the application would go and look only for this chip or a bank of chips. Say you had 100 of your products. You would have your software with the chip ID for every one of these chips connected, and if one of them didn't match, it wouldn't communicate. So that's how it's used in a secure system.
Okay, a good answer.
Good, happy for that.
Yeah. Okay, so there are no other questions.
Excellent. We'll go back to where we were in the presentation, but just to remember, either email Graham or myself if anything else comes up after.
Okay, so I would like to add that we have also, as it was mentioned before, that Tibor Mesaros is a product manager who gives the special technical support for FTDI product. We have also a special microsite about the FTDI. So if you type soselectronics.com and /FTDI, so you can see everything about FTDI products, and also there is a email address for the technical support there. I would like just to ask you, Graham, is it possible to give this PowerPoint presentation to all participants of this webinar?
Yeah, no problem.
Okay, so you can use a function file and transfer in the upper menu in the main screen, and you can add so everybody can download the file. Okay, so while you are doing this, there is another question from Tardy Shandor. Are there any collection of living application examples on the internet?
Is there any, sorry?
And any live application examples on the internet of this collection?
Sorry, I don't know what you mean by live.
So I'm just reading the question.
I know.
So Tardy, could you, if I'm right, so you're not having a microphone, so could you explain in a written mode? What do you mean by this question? Oh, the answer is that he's already found something. So
okay.
It was the code example from C#. That was what he mentioned.
Okay, yeah.
Okay, so the answer itself this question.
Excellent. We do have, we've not mentioned that actually, we do have a lot of software examples in our software link, also within the support section that Graham showed you earlier. He showed you under support and documents. There's also one called code in there.
Oh, okay. So, Jim, you did the wrong step, because in the menu file you chose the third from the down is transfer.
Okay.
Okay, and then you open the PDF file, so everybody can download it. Okay, so now everybody should see the screen with the file transfer, and so you can download the file with the PowerPoint presentation to your computer. So if there's nobody with additional questions, I think we can close this webinar. So, Graham, Kevin, do you have any ideas or any words to say?
I'd just say thank you to everyone for joining the webinar. We hope it's been useful. We appreciate it's not easy to always understand everything from a presentation over 1 hour or 1 hour 20 minutes. Hopefully you've understood that if you need USB as a peripheral or a host, but for X-chip, we can do that for you. We will make it easy. You have to focus on your design. We'll do the USB for you. More importantly, I would really just ask that you please do keep in contact through SOS if you have any questions or requirements. If you want to evaluate the hardware, or if you have a technical question, you want to contact us directly, that's not a problem. We're happy to speak with a customer.
Okay, so me the same. In the name of SOS, I would like to thank to everybody. This was our first webinar, so hope it was useful for you. We will learn ourselves from the small mistakes we did, but hopefully it was okay for everybody. And please control and have a look at our web pages to have information about the further webinars we will have and we will use for you. So after closing this webinar, you will be asked to fill a short survey with just 4 questions to know what we should improve, and hopefully we will meet another time on the maybe another FTDI webinar.
Thanks.
Okay, so thank you everybody, and you can please fill the survey, and you can find every useful information on the Microsoft FTDI. So once again, thank you, and looking forward to seeing at another and further webinars. Thank you.